Hey, what's going on, guys? In this video we are going to see how to solve a first order Bernoulli's differential equation. Now first thing is we have to know how to figure out a differential equation is a Bernoulli's or not. To find that or not, you have to first look at this pattern, and this pattern should be a linear differential equation. Without this y square, you can see this is a linear first order differential equation, because the linear differential equation pattern should look like this: dy by dx plus a function of x multiplies y, that's equal to another function of x. Okay, this is linear first order differential equation. The only difference is we have y square multiplied by this one, therefore this is a Bernoulli's differential equation. And in Bernoulli's differential equation, whatever the value that's multiplying this one, the y power shouldn't be equal to 0 or 1. If it's greater than that, it's a Bernoulli's first order differential equation. Now in Bernoulli's first order differential equation, what we have to do is we have to look at this power. Here is y square, so we have to divide everything by that, whatever the value we have right here. So here we have to divide everything by y square. If you divide this first term by y square, this is going to be dy by dx. Y square will be in the denominator, that will make this one y power minus 2 minus 1 over x. And if you divide this one by y square, y over y square, that's going to be y power minus 1. And then here if you divide this one by y square cancel, we will only have x. Okay, the next thing is we have to look at the value that's multiplying p of x, that's this one, y power minus 1, and we have to equate this one to another term. Here we equate that one to v is equal to y minus 1, and also we have to, okay, this is substitute, and we have to take the derivative of this one, dv by dx. And if you take the derivative of this one, this is going to be minus 1 y power minus 2 dy by dx by chain rule. Now if you compare this one by this one, it's almost same, only difference by the sign, negative sign, right? So if we want to replace this one with in terms of d, we just have to move the negative to the front. Negative dv by dx is equal to y power minus 2 dy by dx. Now we can go ahead and write everything in terms of v. So let's go ahead and write this one. So this is going to be negative dv by dx, and negative dv by dx, that's it for this one, and then minus 1 over x. Instead of y power minus 1, we replace that one with v, and then that's equal to x. Now also to get rid of this negative, we can multiply everything by negative 1. In that way we will get rid of this negative. So this is going to be dv by dx minus, actually this will become plus, and 1 over x v, that's equal to negative x. Okay, now here you can see this is a first order linear differential equation. Now we can solve this one in a usual way. Whenever we have first order differential equation, what we do is we pick up this p of x and find the integrating factor. And you can remember that equation for the integrating factor is given by mu is equal to e power integral of p of x dx. In our case, p of x is 1 over x, because this is a pattern. Whatever the value multiplying y, that's our p of x. In this case, our y is v, so 1 over x is multiplying that one, so that's our p of x. Now let's go ahead and apply in this equation. Mu is equal to e power integral of 1 over x dx. 1 over x is ln of x, so e power integral of 1 over x is ln of x. And you don't have to worry about constant whenever we do the integrating factor, because when we multiply both sides, it's going to cancel anyway, and e and ln cancel. And also you don't have to worry about the absolute value, because even if it's negative, because absolute value means it can be positive or negative, when you multiply by negative, the negative, since the negative both sides, it's going to cancel anyway, right? So we don't have to worry about negative also when we do the integrating factor. Now we found out our value is x, so we have to multiply both sides by x. If I multiply this one by x, dvx by dx, and this is going to be 1 over x, and x cancels each other, and we will get just v, and in the other side negative x square. And after we multiply it by the integrating factor, you know that this thing will be equal to the whole thing when we do the derivative, because that's going to be chain rule, and you will get the whole thing back. So we can directly equate this d by dx vx. I just move this v and x to the front, so d by dx vx is equal to negative x square, and after that we just have to integrate both sides with respect to x. Okay, with respect to x, if you integrate this side, integration and derivative cancels each other, you will get vx. And in the other side, if you integrate negative x square, negative is a constant, so you can move that one to the front, and this is going to be just x cubed divided by 3. So you will get negative x cubed divided by 3 plus a constant. Now finally we have to express everything in terms of y, and we replaced this one. Instead of v, we replaced y of minus 1, y power minus 1 with v. Finally we have to bring that one back. So if we bring that one back, this is going to be just 1 over y times x is equal to negative x cubed divided by 3 plus a constant. And if you want to express this one in terms of y, this is going to be 1 over y, and if you divide this one by x, this is going to be negative x square divided by 3 plus c over x. Okay, and also if you want to write this one in terms of y, you can write this one also, but this is good enough. Okay, that's our final answer for this Bernoulli's differential equation. I hope this helps. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.